Good afternoon. Today we are going to discuss the problems depending on block diagram reduction. So this is the first question regarding block diagram reduction. Simplify the block diagram shown in figure 4 and obtain the closed loop transfer function C of S by R of S, that is output by input. This is transfer function, and the block diagram is given like this. Okay. So first we will take this part. It contains one feedback element, that is H2, and a forward path gain as G2. So we have the formula to reduce this. When the feedback is H2, then G2 by 1 G2 by 1 minus G2 H2. This is formula for feedback. When the feedback is one element and containing forward path gain G2 like this. So this is the direct formula we are applying here. In the same way, here also the same formula we will be applying. Uh, the point here we need to see if here at the summing point, if there is positive here, then we will write here negative. Here it is positive actually. That's why we wrote here negative. Okay. If here in the feedback path entering the summing point is negative, then we will write here positive 1 plus. Okay. Then going to the next step, then there are two forward path gains here. This is one block, this is one block. When these two are connected in series, when the two forward path gains are connected in series, they will be multiplied. Okay. That's it. So these has been multiplied, and also again the feedback path is H3. So we will be uh, subtracting H3 here. Okay. Subtracting here. So applying the same formula, you will get the forward path gain transfer function. This is C of S by R of S. In the same way, we will go for the next question. Right. So this is the question number 2 for block diagram reduction. There are two forward path gains in parallel, and they are uh, merging at summing point. So when the two forward path gains are in parallel, we'll be adding the two forward path gains. This is the formula for this. And the second part, in the same step, we are doing the second part also. Second part, these are forward path gains which has been added, and also at the same time we are uh, applying the feedback path formula also. Okay. Here these are in series, so these two forward path gains will be multiplied, and applying the forward path feedback path formula, you will get the complete block like this. Okay. You can understand here these two are G1 and G4 are in series, that's why multiplied, here also multiplied, and you have the feedback path H1. So this is the formula. In the previous question also we studied the same formula will be applied. Here it is little bit different. The forward path gains are in parallel, so we will be adding here multiplying. That's it. Then here is again another feedback path H2, which contains here negative. So we will be taking here positive. You can see here. See H2. H2 we are taking as positive. Positive here. You can see here. And finally, this is the transfer function. Transfer function. C of S by R of S. Coming to next problem. This is typical. Okay, you have to understand this clearly, and if you have some doubts, you can ask in messages. Okay, so this is the question. Now here is feedback point. Feedback point. There are two feedback points here, so we cannot apply the formula here. That's why we will move this feedback paths to forward. While forwarding, what happens to this feedback path, we will see here. This will be divided by this gain. If I move this feedback path H1 after the gain G3, then this H1 will be divided by G3. You can see in the solution here. See here. In the same way, we have been moved this feedback path, two feedback paths, H1 and H2. These two before G1 to after G1. That's why these has been divided by G3. Sorry, I said G1, this is G3, okay? So these two feedback paths have been moved from before G3 to after G3. So these two has been divided by G3. I think you have been understood. Now we have again here, this part is same, feedback element here, content. So apply the formula. What is the formula for this? These two are in series. So these two will be multiplied and apply the formula for feedback path here. So you will get G2 G3 by 1 minus G2 G3 H3. Okay. Since here it is positive, you can see in the question. Here it is negative. Okay. So in the formula, you will get positive. You can see here. See here. Here it is positive. Since the feedback path has been added to the summing point with negative sign. So here it will be positive sign. You can see. Okay. Then in the next step, again here is a feedback path. Apply the same formula. Here it is negative. Here it is positive. Apply the same. Then these two are in series. Just multiply this G1. Okay. In the next step, and H1 by G3. Again feedback path. Again use the same formula. Here it is negative. Yes, here is negative. The formula will be having positive. This is about the third question, I think. A, B, C, three questions. D is fourth. D. I want to give homework actually. Signal flow graph. Okay, I will give the homework for signal flow graph. Okay, later. So we will go for question number 4 here. Where is question number 4? Here it is. D. Bit D is question number 4. So we have this question like this. So first of all, we will be taking which part. There is a feedback path H3. So due to this, we cannot apply any formula to this block diagram. So we will move this H3 after G3, G4. Okay. So H3 will be divided by G4. That's it. Here you can see in the second step. Okay. Then again, we cannot apply then also. So we will move this feedback path H1 after the big block. After the big block. So H1 will be divided by whole block. How this block has came? How this block has, okay. After forwarding this, you can see here, when you forward this feedback path H3 after G4, then you can see here G3, G4 are in series. So that's why here multiplied G3, G4 in the denominator also. And H2 is the feedback path with negative sign here at the summing point. So apply the formula for feedback, you will get this block. After getting this block, in the next step, we are moving this feedback path H1 after this big block. So the whole block will be divided by H1. In the next step, you can see. See here, in the next step, this whole block has been divided, okay, divided by H1. That is G3, G4 will be divided, is divided uh, by this. So denominator of denominator will be numerator. Okay. And what happens to this block? We will see in the same step. So when okay, this is divided by this. Okay. Now there is feedback path here also. If you forward this feedback gain feedback H1 here, you can see here these two are in series, these two will be in series, so G2 will be just multiplied by this, you can see here, just multiplied by this. So in the second step, in the next step, I mean this step, we applied two formulae. Okay, one is this divided, this complete block gain block will be has been divided by H1, and also after moving this, this will be divided by this, and this multiplied by this. Okay, this is the step. I think you understood. Then coming to the last step, this G1 will be multiplied because of series. Two forward path gains are in series, so G1 will be multiplied, and apply the feedback formula. Here is minus, here will be plus. That's it. I think you understood. Okay? If you have any doubts, you can write me in the course messages, or we can discuss in the next class. So you can see the question here. 1, 2, 3, 4. The last question is signal flow graph. Okay, you need to convert this block diagram to signal flow and apply the Mason's gain formula. Okay? And another question is also there. Maybe one question will be homework for you for signal flow graph. We will see the signal flow graph in the next week. Thank you.